Section 2, temperature is a measure of particle motion. This is in your TCI Weather book, page 21. Cup of water, the air, and the mounds of ice that surround the penguins in the photo in the beginning of the lesson can warm up or cool down as particles speed up or slow down. How does the motion of particles relate to energy? Anything that is moving has energy. Kinetic energy is the energy an object has due to its motion. Objects have different amounts of kinetic energy depending primarily on how fast they are moving and how much matter they contain. Kinetic energy also applies to particles that make up an object. How warm an object is depends on the kinetic energy of its individual particles. People usually use temperature as a way to describe how hot or cold something is. In science, temperature is a measure of the average kinetic energy of the particles in a substance because the particles in matter move at different speeds. The kinetic energy of particles increases as they speed up. Thus, the fast-moving particles in a cup of hot water have more energy than the slow-moving particles in ice. Scientists have devised instruments to measure this kinetic energy in matter. For example, Galileo is believed to have invented the first practical thermometer that could provide this measurement. Temperature and average kinetic energy are related by a ratio. The word proportional describes two quantities that are related by a simple ratio. Temperature and average kinetic energy are directly proportional because temperature decreases as average kinetic energy decreases. What does the very low air temperature in Antarctica tell you about the particles in the air there? What about the high air temperatures in Death Valley, California? These temperatures in figure 2 tell you that most air particles in Antarctica have less kinetic energy and are moving slower, of course, than those in Death Valley. So here's figure 2. Any moving object has kinetic energy. Temperature is a measure of the average kinetic energy of particles in matter. What does the speed of the air particles in Antarctica and in Death Valley tell you about the air temperature in those places? Well, temperature depends on the motion of air particles. In eastern Antarctica, the world record for the lowest temperature at minus 93 degrees Celsius, that's minus 136 degrees Fahrenheit. Fahrenheit is what we generally talk about in terms of temperature, but in the science classroom, it would be degrees Celsius. Cold air, slower particles. Now, they're still particles, and when you take a magnifying glass to them, they just look like they're kind of frozen in space, but they're moving. And in Death Valley, California, the world record for the highest temperature is 57 degrees Celsius. That doesn't sound too hot until you convert it to Fahrenheit, 134 degrees Fahrenheit. Hot air, faster particles.